Hi, this is Algebra 1, Module 4, Lesson 6, Taking Sides. So now we're going to practice and see kind of what is true about inequalities and what are not, and just kind of some um, different ways of looking at them. So Joaquin and Serena work together productively in their math class. They both contribute to their thinking, and when they disagree, they both give their reasons and decide together who is right. In their math class right now, they are working on inequalities. Recently, they had a discussion that went something like this. Joquin, the problem says that 6 less than a number is greater than 4. I think that we should just follow the words and write 6 less than number, so less than minus is greater than 4. Serena says, I don't think that works because if n is 20 and you do 6 less than that, you get 20 minus 6 equals 14. I think we should write in minus 6 is greater than 4. Joaquin. Oh, you're right. Then it makes sense. The solution would be n is greater than 10, which means we can choose any number greater than 10. The situations below are a few more of the disagreements and questions that Joaquin and Serena have. Your job is to decide how to answer their questions, decide who is right, and give a mathematical explanation of your reasoning. So there's 10 of these. First one is they both are assigned to graph the inequality x is greater than or equal to negative 7. Joaquin thinks the graph should have an open dot. Go ahead and mark these as an open dot. Serena thinks it should be a closed dot. Explain who is correct and why. So, who do you think is correct? Well, if it's greater than or equal to, we want to make sure it includes that number. So, it should have a closed dot because we want to include negative 7 in our solution. All right, so Serena was right on that one. Next, they're looking at the problem 3x plus 1 is greater than 0. Serena says that the inequality is always true because multiplying a number by 3 and then adding 1 to it makes the number greater than 0. Is she right? Explain why or why not. Well, if we type this out, I'm going to go ahead and type this one out. 3x plus 1 is greater than 0. Well, let's think about how we would solve this. So we would normally, let's just solve for x and see what happens. Minus 1 from both sides would make 3x is greater than 0. Well, and if we can't really divide by 3 on there, um, actually, yeah, divide by 3, divide by 3. It says x has to be greater than 0. So if I put in here a negative 1, then negative 3 plus 1 would be negative 2, which is actually less than 0. So negatives actually make this not work. Trying to think if there's any others that would, negatives that wouldn't work. So let's try, we said 3 times negative 1. What if we did 3 times negative half? That's negative 1.5 plus 1. That's still too low. Oh, you know what? If we did equals 0, so because we had to divide by 0, that throws it off a little bit. But if we did 3 times a negative 1/3 plus 1, 3 times a negative 1/3 would be negative 1/3 plus 1 equals 0. So really, we want to say x has to be greater than negative 1/3 to make this one true. And that is really our answer on that one. So it does make a difference what number it is. All right, let's go down to 3. The word problem that they're working on says 4 greater than x. Joe Quinn says they should write it as 4 greater than x. Serena says they should write 4 plus x. So um, explain who is correct and why. Um, kind of depends on the the wording. So in this case, 4 greater than x, if I have the number 5, then 4 greater than 5 is 9. So that's a 4 plus x. That means Serena is right, right. Typically for the other one, other is generally said for is greater than x. So that's the difference. Because there isn't an is in there, then it would actually be Serena's right. All right. 4. Joe Quinn is thinking hard about equations and inequalities and comes up with this idea. If 45 plus 47 equals t, then t equals 45 plus 47. So if 45 plus 47 is less than t, then t is less than 45 plus 47. Is he right or not? What do you think? Can we reverse those when it's an inequality? Well, if we actually answer that, 45 plus 47 equals 92. So if 92 is less than t, and we'll say t equals 100, then 100 is not less than 92. Oh no, it's not reversible since it's not equal. It only works when it's equal. All right. Question number 4 made Serena think about other similarities and differences in equations and inequalities. Serena wonders about the equation negative x over 3 equals 4 and the inequality of negative x over 3 is greater than 4. Explain to Serena why that solving these two problems are alike and ways they are different. How are the solutions to the problem alike and different? Well, if we solve the first one, so if we take negative x over 3 equals 4, first we're going to take it times a negative 3 times negative 3. And so therefore x equals negative 12. Now the only difference when we do this the other way is that we have a greater than sign here. So we do the exact same thing times a negative 3, except we would do x is less than, we'd switch that sign, negative 12. So they are similar, they are solved the same way, but the answers mean different things. So the original one, x equals negative 12, there's only one solution. Here we have infinity number of solutions because x is just less than negative 12. So you have one that it has one solution and the other has infinite many solutions. Next, Joquin solved negative 15q is less than or equal to 135 by adding negative 15 to each side of the equality. Serena said that he was wrong. Who do you think is right and why? Well, what operation is between these two? Multiplication. How do you undo multiplication? You need to divide. So Serena is right because you should divide by negative 15 instead of adding it. to undo. So the answer should have been 135. Put that in here. So it'd be 135 divided by -15. So Q, gotta switch the sign, greater than or equal to -9. That's what it should be. Okay, so his solution was Q is less than or equal to 150. He checked his work by substituting 150 in for Q and the original inequality. Does it prove that he's right? Well, yes and no. If he puts in 150, that number is actually greater than Q, but um, there's a lot of numbers greater than, or sorry, not greater than Q, greater than -9. There's a lot of numbers greater than -9. So his number worked, but there are many numbers greater than -9 that would make it true. So that doesn't mean that's the only one. Um, he's still skeptical and believes that he is right. Find a number that satisfies his solution but does not satisfy the original inequality. So we basically need a number that is smaller than 150, but bigger, or sorry, less than -9, because we want to disprove um, that he has the correct answer. So let's just do -10. So if we say x equals -10, x equals -10, or q, sorry, not an x, we have a q right now, q, then -15 times -10 equals 150 positive, and 150 positive is not less than or equal to 135. So really any number less than -9, opposite of what this has up here, opposite of this guy right here, um, would disprove him. 7. Serena is checking her work with Joaquin and finds they disagree on a problem. Here's what Serena wrote. 3x plus 3 is less than or equal to -2x plus 5. -3x is less than or equal to -2x plus 2. X is less than or equal to 2. Is she right? Explain why or why not. Well, let's just go ahead and work through the problem ourselves, right? So if we were to do 3x plus 3 is less than or equal to -2x plus 5. Well, my first step would be to subtract 3 from each side. That gives me 3x is less than or equal to -2x plus 2. Okay, we got the same second line. So from here, I need to add 2x to both sides so that I can make this work. Plus 2x, hope I can still read my lines below. Here I have 5x. 3x plus 2x is 5x is less than or equal to 2. Nope, we don't agree because now we need to divide by 5. Those cancel. X is less than or equal to 2/5. So that's what I end up with my answer. So here's my explanation of uh, she subtracted the 2x on both sides instead of adding the 2x. All right, 8. They are having trouble solving -4 parentheses 3m minus 1 and end parentheses is greater than or equal to 2 parentheses m plus 3. Explain how they should solve the inequality, showing all the necessary steps and identifying the properties you would use. Okay, lots of steps on that one. So let's start with -4 parentheses 3m minus 1 greater than or equal to 2 parentheses m plus 3. So, couple of things we could do. Let's just go ahead and distribute everything to get rid of these parentheses. So if I were to distribute, I'd have negative 4 times 3, which is negative 12m. Negative 4 times a negative 1 is plus 4, greater than or equal to. Distribute my 2. 2m plus 2 times 3 is 6. Okay, so from here, I think I'm going to subtract 4 from both sides. Those cancel. That leaves me 12m is greater than or equal to 2m plus 2, right? Plus 6 minus 4. All right. Um, now I need to get the 2 moved over. So minus 2m. Oh, this is a negative. Make sure I keep my negative there. Minus 2m. Those cancel. That gives me negative 14m greater than or equal to 2. And now I need to divide by the 14. Divide by negative 14. And so I can actually simplify this one. And I am greater than, so I need to flip my sign because I'm multiplying by or dividing by a negative. 2/14 is negative 1/7. So I started by using my distributive property. Next, I used my subtraction property of equality. I used another subtraction property of equality, and then I did a division property of inequality. And that gives me my final answer of m is less than or equal to negative 1/7. All right, almost done. They know some equations are true for any value of the variable, and some equations are never true, no matter what value is chosen for the variable. They're wondering about inequalities. What can you tell them about the following inequalities? Do they have solutions? What are they? How would you graph them on a number line? So 4s plus 6 is greater than or equal to 6 plus 4x. So for this one, they're exactly the same, right? If I can subtract 6, that would be 0 on both of them. Subtract 4s, that would be 0 for all of them. So they're always going to be equal. So I'm going to go ahead and erase those on there. So these are always going to be equal since we have that equal sign in there. Our, what did it say too? What are they? How would you graph their solutions on a number line? So let's go ahead and just put our notations here. So set notation would be S for all real numbers. And then the other one, I need to do my equations here. So then this one, if I were to do my interval notation, then it would be negative infinity. Oh, I lost my box. So it would be negative, oh, parentheses, negative infinity, comma, infinity, right? Because it would be, I would actually be able to use any number and they would be the same. All right, so this one, if I go to solve it, let's go ahead and just switch colors for this one so we're not getting confused. If I add 2, and I subtract 3r. Oh, I subtract 3r. My 3r's would cancel. So then I would have 7 is greater than 0, which is true, right? So any number, if I add 5 to one side and I subtract 2, erase these out here. So if I have any number and I'm So 3r is going to be the same no matter what, right? Adding 5 is going to be bigger than subtracting 2. So this is another one where we have the same basic um, set notation and interval notation that we would have on the other one because all real numbers, doesn't matter what number I put in there, it's always going to be true. So R is real numbers. And then when I do set notation, we'll go ahead and do that over here. We're going to have the same thing, parentheses, negative infinity, comma, infinity. Any number works. All right, last one. 4 parentheses n plus 1 is less than 4n minus 3. So if I'm looking at this one, we're going to distribute here. Let's go ahead and we'll do this one in blue. Distribute, I'm going to get 4n plus 1. Oh, not plus 1, plus 4, distributed to both, is less than 4n minus 3. Now, if we look at this like we did last time, notice that 4n is the same on both sides, right? But here I'm adding 4, here I'm subtracting 3. There's no way if I'm going to add 4 to one side and then subtract 3 from the other side, my plus 4 is going to be smaller. So this is not true for any of the equations. So not true for any number, any real number. And so that would be no solution, and meaning nothing's going to be on that number line. Basically, be empty. Okay, the partners are given the literal inequality of ax plus b is greater than c to solve for x. Joe Quinn says that he will solve it just like an equation. Serena says that he needs to be careful because if a is negative, the solution will be different. What do you think? I'm actually going to do it down here. Let's go ahead and solve this for what they're saying. So let's go with green on here. All right, so ax plus b is greater than c. So first we'd have to subtract b from both sides, right? And that leaves ax is greater than c minus b. Now here's where the problem is. If a is positive, our sign stays the same. But if a is negative, it will switch. So from here, if a is positive, then it's going to be divide by a on both sides, right? And it is, if a is positive, let me write that a little more clear. A is positive, then x, wrong letter, x is greater than c minus b over a, right? My sign will stay the same if it's positive. If a is negative, then I have to switch my sign. So x would have to be less than c minus b over a. So yes, it does make a difference. What if a is 0 though? If a is 0, then can we divide by 0? Nope. Then no solution. So isn't it saying b is bigger than c, and we don't really know if that's true or not. We can't divide by a. Thanks for joining us today, and we'll see you next time.